Welcome back. Yesterday you have built your first simple model, a tiny linear regression that predicted exam scores from study hours. Today we'll open up the world of learning styles in ML, how machine learning actually learns depending on the kind of data we give them. By the end of the session, you will be able to look at any problem and say, ah, that's supervised problem, or this looks like unsupervised learning. Humans learn in different ways, sometimes with guidance, sometimes by exploring. Machines are the same. In ML, there are four main learning types. Supervised learning learns with guidance. Unsupervised learning, discovering patterns on their own. Semi-supervised learning, a mix of both. Reinforcement learning, learning by trial, error, and reward. Let's understand each with story and small coding experiments. Supervised learning, learning with a teacher. Think of supervised learning algorithm as a student with a teacher. Teacher provides questions and correct answers, data and labels, and the student learn from those pairs. The goal? Learn the rule that connects the input to output so it can predict the answer for the new questions later. Imagine you run a used car website. You have a data set of cars like features like age, mileage, brand, and engine size, plus the selling price. You want your computer to predict the price of a new car. That's supervised learning. The model sees examples where it knows the correct answer and learns to generalize. Let's try predicting the house price. Don't worry, you don't need a real data for now. We'll just simulate it. Here, each x is the house size and y is its price. The model learns the price increases roughly 20k per extra 1000 square feet. That's regression, one branch of supervised learning, predicting continuous values. There are two kinds of supervised problem: regression for continuous values, classification for categorical labels. When your output is a number, it's regression. And when your output is a label, it's classification. Let's see a demo for classification with iris dataset. This time, the model classifies the flowers into species based on petal and sepal measurements. We give it labeled example. That's why it's supervised. It learns the pattern and achieves an accuracy score, telling us how well it understood. Pause here and think. What problem in your life could be solved using supervised learning? Predicting your electricity bill? Detecting spam SMS? Jot on the ideas. Now let's switch gears. What if you don't want labels? You have raw data, customers, transactions, images, but no categories. You just want to see patterns, groups, or structure. That's unsupervised learning. The model explores and discovers itself. Suppose you own an online clothing store. You have thousands of shoppers, but no idea how to categorize them. You feed their purchases history to an ML and it clusters customer into group. Maybe budget buyers, trend seekers, and premium lovers. The model did this without being told. That's unsupervised learning. Let's try k-means clustering, a demo for unsupervised learning. Picture dots on a scatter plot. The algorithm draws invisible circles around the group of similar points. Each cluster center is like a representative of that group. Some common unsupervised tasks are clustering for grouping similar data. An example would be customer segmentation, and dimensionality reduction, simplify the complex data, PCA on image dataset, anomaly detection for spotting outliers. An example would be fraud transactions. These algorithms are like detectives. They look at the data and whisper, I see three main patterns there. Take a quick note. What's one data set or situation in your world where you have no labels but still want to find pattern? Maybe songs with similar moods or grouping your old photos. Sometimes labeling data is inexpensive or time consuming. Think of medical scans. Each has to be labeled by a doctor. You might have 500 label scans and 10,000 unlabeled ones. Instead of wasting the unlabeled data, you can let the model learn from both. That's semi-supervised learning. It's like a class where the teacher only grades a few assignments, but the students still learn from seeing everyone's work. The model uses few labeled examples as the anchor and learns from the pattern in the unlabeled data into improving accuracy. Real-world datasets are rarely fully labeled, so this type of learning is extremely practical. You will encounter it often in fields like speech recognition and image tagging. Finally, we come to reinforcement learning, the most exciting and human-like learning method. Here the model called an agent learns by interacting with the environment. It observes what happens and gets feedback, a reward or penalty. Over time, it figures out the best strategy to maximize the reward. Think about how you learned to ride a bicycle. You wobbled, fell down a few times, adjusted your balance, and eventually learned what keeps you upright. That's reinforcement learning. Learning from trial and feedback. Some real world examples for reinforcement learning will be game playing AIs, AlphaGo or chess engines, self driving cars like Tesla, robots learning to walk or grasp objects, recommendation systems improving through user clicks, etc. In each case, the system isn't told the right answer. It discovers it through experience. Let's imagine a mini robot in a maze. Each time it reaches the goal, it gets 10 points. If it hits a wall, it gets negative point. After hundreds of runs, it learns the shortest path automatically. That's the essence of reinforcement learning. Learning from consequence. So a quick recap. Supervised learning needs label, and an example would be predicted house price. Unsupervised does not require label, it does by finding a structure. Semi-supervised requires some label and it trains by using few labels to guide the unlabeled data. And reinforcement basically works on rewards with trial and error feedback. Take a deep breath. You have just learned the 4 pillars of machine learning. Understanding these help you choose the right approach for any problem. Mini quiz. Which learning type works without labels? If a system gets points for winning and penalties for losing, what kind of ML is that? Which method would you use if only part of your dataset has correct answer? Regression versus classification. What is the main difference? Think of your favorite app, maybe Spotify, Instagram, or Google Maps. Which type of ML do you think it uses and where? For example, Spotify uses unsupervised learning for clustering songs, supervised learning for genre classification, and reinforcement for improving recommendation. Write your thoughts. Tomorrow we'll connect these ideas when we learn about AI versus ML versus deep learning. See you soon.